quantity which has only 9. So if you look at we use, I won't write a definition, but what we'll do is for vectors notation. This is very, very critical. If you mess this up, you will lose your points in exam. Don't mess up notation for vectors and scalars. Vectors we use a underline. Okay. Scalars it will just be that symbol, letter. Okay. So here V, A, these are all vectors. Got it? Without a underline, that would be a scalar. Okay. And your basic.
Is it really put S twice, or you just put it twice?
This is capitalized. This is lowercase. Okay. So you can use lowercase and uppercase letters for vectors and scalars. The difference is the underline. In the textbook, what you want to notice is this is the textbook we'll be using. Algebra mechanics for engineering students. Okay, it's the 3rd edition. In this, vectors are denoted by bold case. There is no underline. We cannot do the bold case on board. We won't be able to distinguish it properly. Okay. But in textbook, it is bold case. Vectors are bold case.
Yes, sir. But you don't care about the capitalization as long as it doesn't have an underline.
Yes.
Correct.
Yes. It doesn't matter if most of the time what's going to happen is I'm going to give you the vectors.
Okay.
And you need to use that same thing. But when you do the operation from vectors, that's when you make sure you use the right operation, right notation.
What is the B symbol? The B?
It's just notation for a vector.
So
Here, all these are physical quantities. It doesn't represent anything right now. Okay? This is not necessarily velocity. No, it's just a vector. This is a vector V. It could be velocity, it could be position, it could be acceleration, it could be force. Okay. A is again just a vector. It could represent anything. But it is a vector when we have it. This cannot be mass. Because mass is a scalar quantity. You have to use, if you want to use mass, you have to use one of these or any letters for that matter. You can use Greek letters as well. Vector operations. Vector and scalar operations. These are basic vector operations. Okay. So we'll look at scalar operations or vector operations. The first is
what edition did you say the book was? 3rd edition.
here there are, what is this? Magnitude of a vector. This is a vector itself. This becomes a unit vector. If you take a vector, divide that by its magnitude, you're going to get a unit vector. Okay? Unit vector is essentially a direction vector. It will tell you only the direction. But what is the magnitude of a unit vector? 1.
So the 2 lines represents magnitude.
2 lines represent magnitude.
And what question you asked? What was the question you asked?
What is the magnitude of a, for a unit vector? Magnitude of a unit vector is, okay. This becomes this. Does that make sense? This A, magnitude of a vector is what? A scalar. No, magnitude of a vector is, unit vector is 1. Magnitude of a vector is just the scalar. Okay? If you take the magnitude of a vector, it is just a number. Okay? So you can write this as like this.
No, I can write what it is. I can write what it is. That is that. So those lines really aren't that deep.
Yeah, it just means. So an example would be, how do you represent vector? Now, if you have, we'll use this representation. This is what I need you to distinguish. Mathematical representation. Will stick with or will use this representation. If you have a vector A, we'll use this. AXI plus AYJ plus AZK. Okay? Does this make sense? An example would be, okay. What is AX? What I would strongly recommend is try not to take notes. You may lose the narration and you may lose. If you take notes here, you need to go back and review the lecture.
So AX is 1.
Yes, AX is 1. AY is -4. AZ is 8. So with regards to taking notes, I would strongly recommend that you don't take notes. You just pay attention. Go back and prepare the notes again. Or just take a picture of this and then prepare the notes. Okay. So what is how do you calculate this? You have already learned this. This is A, right? Is simply equal to square root of ax square plus ay square plus az square. So this will be 1 plus 16 plus 64, right? This is 81. So A is okay. This is this part. Now, what is UA? It is simply 1 over 9 I minus 4 over 9 J plus 8 over 9 K. Does that make sense? You have to look at what is the coefficient of I? 1. 1 over 9. You multiply each of the coefficients by 9. Here. Got it? So you're going to get this. If you take the magnitude of this, how much are you supposed to get? 1. And I can show you that it's 1 over 81 plus 16 over 81 plus 64 over 81, right? This would be 81 over 81. Okay. So this is the unit vector. This is the magnitude, and this is how you represent the vectors. Okay. You have to look at what is a vector itself. Let's look at the position vector. Here, this is your I, J, and K. Got it? This is your vector A. Does that make sense? The component of A in the I direction is 1. Got it? The component of A in J direction is minus 4. The component of K in the K direction is 8. So AX, this is how the vector is split. Okay. So the magnitude is essentially, what is the magnitude? Magnitude is the length of that vector. That is the magnitude. And this gives you the direction of that vector is this. Does that make sense? Any questions with regards to that? What is direction a function of? Direction is a function of the established basis. What is the basis here? IJK. Got it? So think about this. What is let's look at that light or the fire alarm. Okay. If you look at the basis, what is the basis here? This is your x direction. Okay. This is your y direction. This is your z direction. Right? The position of that, the position vector will be so many units in x direction, so many units in y direction, and so many units in z direction. Okay. That is the vector. You understand? That is the position vector of this thing from this origin. If we change the basis, will the direction change?
Yes.
Will the magnitude change if we change the direction of this basis?
No.
Magnitude does not change. So magnitude remains the same. Okay? So that is what we need to learn. You want to take a picture of this? Want to take a picture of this?
That's on the board, like, is that visible?
Hmm?
Is that visible?
That's not quite visible, so I don't especially in the. You got it? Keep in mind if you have vector A, vector addition and subtraction, you have A plus B, it's simply equal to AX plus BX, right? Plus AY plus BY. Of course, you have to have your I, J, AZ plus BZ. Okay. The prerequisite for this is if you want to add two vectors, they have to be expressed in the same basis, in the same reference. You got it? So if you look at, if you want to add, what does a vector addition give you? If you have this vector A and this vector B, what is A plus B?
It'd be the little part right here. It'd be this part. You just label it whatever, I guess.
Here, what you need to understand is the tail of the first vector, alright? If you look at this, and the head of the second vector need to be added. So here, what you're going to get is, if you have this, what you're going to do is, this is A plus B. What I did was, this is A, right? I took this, I attached the tail of vector B to the head of vector A. And then I join the tail of vector A and head of vector B. That is A plus B. What?
Do you have to call it A plus B? Do you have to call it A plus B?
You can call it C or A plus B. So what would A minus B be?
Wouldn't it be the same vector distance but like in different position?
So here, if you look at A minus B, you're again going to do the same thing. You're going to do, you have this. You have this. And what is this? Minus, right? Because I changed the direction. I just have to. What is this vector? A minus.
Question. Alright, so you see you have at the top, like all at the top. So it's vectors A plus B equals X, right? Yeah, okay, so what's that? AC plus B.
Right, if you have A like this, what will be your B? If you have A like this, your B will be BX, BY, BZ, right? It will be in the same basis. It has to have the ijk basis. You cannot have vectors in two bases and then add them. That's not allowed. Okay? It essentially means if you want to figure out the distance between that, okay, that fire alarm and let's say this vent, right? It's that vector, right? But it has to have the same basis.
So that's AZ.
The xyz has to be the same. You have to express this vector plus this vector, and then you take the addition will give you that. The subtraction will give you. Okay. So the addition will, you have to move this vector, and then it's essentially this plus that. The subtraction will be this vector. The subtraction is this, the distance between that. Got it? Okay. Now, vector multiplication, this is very important. Vector multiplication is not defined. Got it? There is no vector multiplication, there is no vector division. What that means is A, B, not defined. A divided by B, not defined. Keep in mind. Okay, if you do this, huh?
The little swirly thing that means not defined.
Yeah, this is not, you cannot have this. You cannot, there is no operation like this. So instead what we do is, we define, we finish with this dot product and cross product. A dotted with B is what? Anybody remembers?
It's dot product. It's 0.
No, it's not 0. It is essentially A, the magnitude of A, magnitude of B into cosine of theta. Okay? Or the other way of writing it is, of computing it is, ax dx plus ay dy plus az dz. Got it? Any questions here? We'll finish with this cross product and I'll give you an example. What is this? A, B, sine theta, and this will be a vector in the direction of perpendicular. AB. Okay. It's, I'll give you this perpendicular EB. So what that means is if you have two vectors, right, the cross will be perpendicular to those. If these two are the vectors, where is the perpendicular to this?
Which one?
AB.
So it's perpendicular.
Are you asking for like the answer, or because I was just going to say the equation?
No, what is this vector? It is this. That makes sense? This is perpendicular to A and B.
It's really simple. make sense. I'm just like,
Okay, this is the only. So if you have to keep in mind that A cross B is not the same as B cross A. We'll talk about that. A cross B is what? In fact, the perpendicular, it will be going inside the board.
A cross B.
A cross B, it is. So if you have, it's like this. Okay, it's A cross B. If you have, think about this. B cross A would be this. Okay, the vector is coming out. Your thumb is the vector. Your A cross B is this way. A cross B. Does that make sense? The vector is going inside. Got it? So the vector here is going inside. If it is B cross A, it is coming outside. Right? And this is the dot product of, this is the projection of A on B. Right? It's a scalar quantity. A dot B is equal to B dot A, but A cross B is equal to minus B cross A. This is the commutative property and this is the anti-commutative property. Okay. Any questions? You want to do an example on this one, or you're good? You can figure this out.
We're going to figure it out.
You can figure it out, right? I think I'll give you an assignment where you should be able to figure it out.
Did you give me some yesterday?
I will post it today. Any questions? You good with this, Boris?
Yeah, I just figure out that.
oh, it's right here.
It's better than my computer?
Yeah.